Let's take a look at this example. This time we have angle alpha given in radians. We have given length of side B. We're supposed to find the length of side C. We're supposed to find the length of side A and angle beta. Please keep in mind that we practice different options to solve the problems, and this time we will use tangent alpha to find the length of side A. Why I start from tangent alpha? Just to show you that there are different ways to solve these kind of problems. Of course, someone is going to say, I can also use, for example, cosine alpha to find C. Yes, this is true, because alpha is given, side B is given, and we can find length of side C. Someone is going to say, what about sine alpha formula? Alpha is given, A is not given, and C is not given. So that's why I cannot use this formula at this moment. Why? Because I have just one piece of the information. You prefer, you must, I'm supposed to say, no, you must use the formula which contains two pieces of information. Sine A has just one piece, that's why I'm not going to use it. So, tangent alpha is equal A over B. Alpha is given, B is given. I can solve this formula for A. Multiply both sides of the equation by the denominator because I want to eliminate the fraction. B and B will cancel out. And I have A equals B tangent alpha, where B is equal 342 millimeters times tangent of 1.04 radians. So A is equal 582.63 millimeters. Please keep in mind, anytime you will deal with radians, your calculator must be switched to radians. If you are going to have calculator switched to degrees, your answer is going to be wrong. So this is the length of side A. In order to find the length of side C, you can use the formula for sine or for cosine. Why? Because alpha is given, A we just found, so we can find C. We can also use cosine formula because alpha is given, B was given, and we can find C. Tangent doesn't contain C. That's why we cannot use this formula. We can also use Pythagorean theorem. And this is basically what I'm going to use. So we have C squared is equal A squared plus B squared. Someone is going to ask again why you are using Pythagorean theorem. I just want to show you that there are different options to solve this problem. So we have C equals square root of A squared plus B squared. This is equal square root, open parenthesis, and I have A, which is equal 582.63 millimeters raised to the second power, plus B, which is equal 342 millimeters raised to the second power. This is equal 675.59 millimeters. And this is the length of the hypotenuse, side C. In order to find angle beta, you're supposed to keep in mind that alpha plus beta is equal 90 degrees, but this time we are dealing with radians. 90 degrees convert to radians is equal pi over 2 minus given angle. And alpha is equal 1.04 radians. Plugging these values into the calculator, you're supposed to get 0.53 radians. Okay, we found the length of side A, we found the length of side C, we found angle beta, so we can say that problem is solved.